Good morning, students. So in last class we are discussing about theories of complex compounds. So all theories we are completed. So mainly in our theory part we have three theories are there. So first one is Werner's theory, second one is VBT, valency bond theory. Next third one is after failure of VBT, CFT is came. So crystal field theory. So next after that the important concept is there, isomerism. So now we are going to discuss about isomerism. See, iso means same. Merism means exchange, otherwise difference. See, in the organic chemistry it is famous isomerism, but anyhow here also it is related to covalent bonds. What will be the same? So same molecular formula. What is different? They are showing properties. See, the compounds which have same molecular formula but they are showing different properties are called as the compounds which have same molecular formula but they are showing different properties. Are called as isomers. Called as isomers, that phenomena is called as isomerism. So this isomerism mainly classified into two types. One is structural isomerism. Second one is stereoisomerism. Again, this is structural. So the means it is depending on the structure. So stereo. What is the meaning of stereo? Means around the functional group, three-dimensional space. So around the functional group, three-dimensional space you called as stereo. So the compounds which have same molecular formula but they are showing different properties through the difference in the stereo, then they called as stereoisomers. Here the compounds have same molecular formula but they are showing different properties through the difference in the structure. Whatever the name we are provided, that is the difference. Then you called as that isomerism. So structure is classified into many types. First one, so hydrate isomerism. So hydrate isomerism, otherwise solvate. So also called as solvate isomerism. Next, second one, linkage isomerism. Next, ionization. So ionization isomerism. Whatever. So in ions different are there, ionization. In linkage different is there, linkage isomerism. Hydrate. Otherwise the number of solvate molecules are different, means that is hydrate isomerism. Fourth, coordination. Coordination isomerism. So next, coordination position. Coordination positional isomerism. So this is the extra point compared to your theory also. Next, sixth one, polymerization. So these are the main important structural isomerism. So stereo is mainly classified into two types. So that is one is geometrical. One is geometrical isomerism, another one is optical isomerism. See, in geometrical, how to identify the geometrical means, in geometrical you are getting cis, trans, next E, not EZ. So you are getting cis, trans. So how you can identify it is a geometrical isomerism? So you must identify distance difference. Distance difference between ligands is possible, and one more than one structure. More than one structure is possible to write. Then directly you can say it is geometrical isomerism. So everything we will discuss, but main important points. So geometrical means you must remember cis, trans. How you will identify distance difference between ligands is there means directly you can tell geometrical. Otherwise you can write more than one structure, that is also geometrical. Next, optical. So this is absence of a plane of symmetry. Absence of plane of symmetry is there. So direct you can remember. So absence of plane of symmetry means optical isomerism in your organic chemistry also. What are the plane polarized light rotation? PPL rotation. So plane polarized light rotation is happened means then you can tell directly that is optical isomerism. Next, generally chiral center. So the central metal is surrounded with four ligands, four different ligands. Then it is chiral nature. Four different ligands. Otherwise, simply plane of symmetry is absence. Then also optical isomerism. Once again, we will discuss all those things. But first one brief idea. So you will. So now we are going to discuss about structural isomerism one by one. So first one, in structural isomerism. See, how to write that definition means the compounds which have same molecular formula, but they are showing different properties. So they are showing different properties through difference in the structure. Through difference in the structure. So are called as a structural isomerism. So definition you must write like this. Next, in structural isomerism, one by one we will see. So first one, hydrate isomerism. Hydrate isomerism, otherwise solvate isomerism. See, What will be the definition of this? The compounds which have same molecular formula but they are showing different properties through the difference in the hydrated or solvated molecule. Difference in the hydrated or solvated molecules. So everything is the same, but this last only you must concentrate. Previous structure is there, structural isomers. Hydrated. See, suppose we are seeing COCl3 excess ammonia. Already we are seeing what you are getting. 4 compounds are getting. So this only we can write in what way? CONH3 taken 6. 3 chlorines are outside. 0 ammonia. So this is A compound. Next, B compound. CONH3 taken 5. 1 Cl inside. 2 chlorines outside. 1 ammonia outside. Next, C compound. CONH3 taken 4, 2 chlorines, Cl, 2 ammonias. Next, D. CONH3 taken thrice, Cl3, 3 ammonias. See, instead of ammonias you are writing water. Then it is called as a hydrated isomerism. So these 4 compounds you called as a hydrated isomers. Suppose instead of water ammonia is there, so then you called as a ammonated isomerism. So these are instead of water hydrated you called as ammonated isomerism. See, ammonia is nothing but water solvent only. So that's why we are called as a solvated isomerism. Instead of ammonia, water is there. You called as a hydrated isomerism. So these are the best examples. Next, second one. Ionization isomerism. Second, ionization isomerism. So here, what will be the definition? The compounds which have same molecular formula, but they are showing different properties through the difference in the outcoming ions. In the outcoming ions in solution state. So this point is extra, remaining everything is the same. So now what will be the examples? So any negative ligands are there. So different negative ligands are there in the complex means directly you can tell this is ionization isomerism. See, you take so Fe H2O taken for Cl Br C. Suppose this type of a complex is there. So iron surrounded with 6 ligands, outside 1 more is there. So in this oxidation state it is 0, these are 3. -3, so it is a +3. Suppose this is taken into the water, then what happens? Already Werner told this is a primary valency or ionizable valency. Who are outside of the square brackets only coming outside into the solution. So you are getting Fe H2O taken for Cl Br and plus and Cl minus. So you take this complex into water means which ion is coming outside? Cl minus ion is coming outside. Suppose another one you take FeH2O taken 4Cl2. Now bromine is outside. In the water you take. Then what happens? So bromine is coming outside. So FeH2O taken 4Cl2 plus Br minus. So outcoming ion. See, this complex formula is the same. 2 irons, water 4. Here 2 chlorines, 1 bromine. Molecular formula same. If you put into the water, what happens? Outcoming ions are different. So that's why it is called as ionization isomerism. If any negative ligands are there, directly you can tell it is ionization isomerism. Next, third. So linkage isomerism. So again here, the compounds which have same molecular formula but they are showing different properties through the difference in the linkage atoms. In the linkage atoms of ligands to central metal. This point is extra. So the compounds which have same molecular formula but they are showing different properties through the difference in the linkage of atoms of a ligand to the central metal ion in complex. So now where these are observed means whenever ambidentate ligands. So how to remember this one means if complex contains ambidentate ligands, then they will show direct linkage isomerism. So what are ambidentate ligands means? CN, you write as cyano. So N is connected, isocyano. Next CNO, cyanato. Next NCO, that is isocyanato. Next SCN, thiocyanato. Next NO2, nitro N, otherwise ONO, nitro O, otherwise nitrito. So here this is also called as cyano C, this is also called as cyano N. So already we discussed in the nomenclature of the complex compounds. This type of ligands are there. Directly you can tell that is what? Linkage isomerism. Suppose if you take example, so K4 FeCN taken 6. Next same K4 FeNC taken 6. So by seeing formula is the same, but here carbon connected with iron, here nitrogen connected with iron. So here what happens? Cl. Iron is connected with carbon, but here what happens? Iron is connected with nitrogen. See the difference. So whenever this type of ligands, directly you can tell. That is what? Linkage isomerism. Next, fourth one. Coordination isomerism. See, the compounds which have same molecular formula but they are showing different properties through the difference in the coordination. What is coordination? The ligands surrounded to the central metal. The ligands surrounded to the central metal ion. So that is called as a coordination. Now, we can see the examples. So platinum is surrounded with ammonia, 4 ammonias. Nickel is surrounded with chlorines. So this is a complex. Platinum is surrounded with ammonia, nickel is surrounded with chlorines. So now another example I am taking. Platinum is surrounded with 4 chlorines. Nickel is surrounded with ammonias. Otherwise, so platinum surrounded with 3 ammonias, 1 chlorine. Nickel is surrounded with 1 ammonia, 3 chlorines. Otherwise, reverse. So platinum is surrounded with 1 ammonia, 3 chlorines. Nickel is surrounded with 3 ammonias, 1 chlorine. See, if you see this, platinum, nickel, here also platinum, nickel, 4 ammonias, 4 ammonias, 4 chlorines, 4 chlorines. So molecular formula is the same, but platinum is surrounded with ammonia. Platinum coordination is ammonia, nickel coordination is chlorine. But here what happens? Platinum coordination is chlorine, nickel coordination is ammonia. So like that, these are also examples. Every one is that is coordination around the metal you observe, that is the coordination. If difference is there, directly you can tell that is coordination. So additional one point is there, coordination position. So coordination, positional isomerism. So this is one additional important point. So here the name itself is there. So coordination is different and as well as position also different. And position also. So where it is happened? So it is happened in bridged ligands. Bridged ligand complexes. So in bridged ligand complexes only it is observed. So one example you can take. So cobalt, ammonia 4, NH2, next OH, cobalt 4 chlorines. This is coordination. Coordination means this is surrounding. Next, another one. You take ammonia twice, chlorines 2, cobalt, NH2, cobalt, Cl2, NH3, take OH. So if you see this cobalt surrounding is complete 4 ammonias, but this cobalt surrounded with 2 ammonias and chlorines. See, this is coordination is different and their position also different. Ligands, here 4 ammonias are one side, but here 2 and 2 are both sides. So position also, ligand position also different, coordination ligand also different. So that's why these are called as coordination position. Next, last one. Polymerization. So the name itself there, poly means so many. So monomer, dimer, trimer, like that. Difference. So they are showing different properties through the difference in the polymetals and polyligands. So poly is nothing but so many. So if example we seen means so platinum Cl2 NH3 taken twice. Suppose another complex you take platinum Cl4. Next platinum NH3 taken 4. So you comparison this first and second. Here one platinum, here two platinums. Here two ammonias, here four ammonias. Here two chlorines, here four chlorines. So this complex is a double of this. So that's why it is a monomer. So this is a dimer. So three types are coming. Three platinums you are taken means that is a trimer. So like that one complex double is a dimer, triple is a trimer, like that. So this is a polymerization, isomerism we call this. Okay, this is.